In this video, let's understand the line angle structure for an organic molecule. Let's convert this into a Lewis structure. On the surface, this looks funny. It looks just like a straight line with a couple of other lines. In a line angle structure, you might expect some zigzag shapes, but this one doesn't have any zigzag shapes, and there's a reason for that. This is a hydrocarbon. It's a molecule that contains only carbon and hydrogen. If there are heteroatoms or atoms other than carbon and hydrogen, we have to draw those in here. We have to show the elemental symbols. Otherwise, we assume every end of a line is a carbon atom, and every corner or zigzag corner is a carbon atom, but we don't have zigzag corners here. What we do have is this single line that abruptly changes into three lines or triple bond. So that's a change, but there's no corner. We're not zigzagging here. So let's go ahead and draw this skeletal structure. And then this triple bond is going to be between two carbon atoms. Again, here you've got a triple bond that abruptly changes into a single bond. And the reason why there's no zigzag here, this is written as a straight line, is because if you studied your hybridization, the carbon here with a triple bond surrounded by just two groups or two atoms, this is sp hybridized. And so the bond angle here is 180 degrees. So it's called a line angle structure, which I've explained in earlier videos. But there's no zigzag here. There's no corner. It's just a straight line. So the total here are 4 carbon atoms. And we'll go ahead and add the hydrogen, the rule here. We assume there's enough hydrogen to satisfy the octet rule for carbon or making carbon tetravalent. The carbon at the end has 3 hydrogens. I'll go ahead and draw it like this. So the carbon at the end still has that tetrahedral shape. I'll go ahead and draw the wedges and dashes. So for a tetrahedral, we have bond angles of 109.5, 2 groups in the plane, and 1 group with a wedge coming out at you, 1 group with dashes going into the paper. Great quiz and exam questions. Prepare for this, Organic 1 students. How many hydrogens around this carbon? We want to make carbon tetravalent, give it 4 bonds. This carbon already has 4 bonds, so 0 hydrogens are bonded to this carbon and 0 hydrogens bonded to this carbon. The carbon at the end, very similar to this carbon at the end. I'll go ahead and draw it this way. Give it 3 hydrogens. And the functional group right here, the alkyne. Let's go ahead and build it with the model. So zooming out just a little bit here so we can see it. There's our alkyne functional group. It's the carbon with the triple bond. You notice the carbons at the end. sp3 hybridized still have the tetrahedral shape, bond angle of 109.5. You can see those 2 groups here. These hydrogens, one pointing towards you in the wedge, one pointing away from you in the dashes. And then the same thing down here for the last carbon. And the other noticeable characteristic, that 180 degree bond angle around those 2 middle carbons. You see, it's just looks like a straight line.